This is video R4, and we're going to be talking about quadratics. We spent a tremendous amount of time on quadratics when we did them in class, so hopefully all of this is going to be reviewed for you. We're going to first of all look at x squared minus 7x plus 12 equals 0. This is a quadratic. We know it's a quadratic because it has an x squared. First thing I want to point out is we learned that this leading coefficient tells us whether this opens up or opens down. As long as this is positive, this is a smiley face, it opens up. If this is a negative leading coefficient, had this been negative x squared or negative 2x squared, then this would have been a frowny face. It would have opened down. Another reminder that anytime you're dealing with a quadratic or any sort of polynomial, whatever you have here on the end as the constant is the y-intercept. So this crosses the y-axis at y is equal to 12. Important thing about quadratics is finding the x-intercepts, the solutions, the zeros of the function. There are numerous ways to find that. First of all, you can graph in order to find them. Here's an example of a graph of a quadratic. This graph of the quadratic has two x-intercepts, one here and one here. You can do second calc 0 on your calculator in order to find those values, or trace with your calculator in order to find one that's fairly close. If you have only one solution, we call that a bounce. It means that you have the same x-intercept twice, same factor twice, same solution twice, and it simply bounces off. Now that doesn't have to happen at 0, 0. It can happen somewhere else, and this can open up or open down. If your solutions are imaginary, then we really have no solution. We have no x-intercept. We either have this situation or this situation, but it never crosses this x-axis. You don't have to graph to find the solution. Another way to find it is to use the program Algebra 2 and Quad. This uses the quadratic formula in order to solve a quadratic function. The quadratic has to be in standard form in order to use this. Ax squared plus bx plus c equals 0. Remember, if you have to change sides of an equation with some number, change the sign. For example, if this had been a negative 12 on this side of the equation to start with, we would have moved it to the other side and it would have become a positive 12. If you change sides, you change signs, and it has to all be on one side of the equation in order to use that program. One other thing that you will find in that program at the bottom of this page, you'll find d equals. Remember, that stands for discriminant, and the discriminant tells you how many solutions there are to the quadratic. If that discriminant is positive, then that means that there are two. If it's 0, it means that there's only one. You've got to bounce. If the discriminant is negative, that means that there are no x-intercepts. That means your solutions are imaginary, and therefore it's never going to cross the x-axis. Now, what if we have factored form where we're able to factor these? Well, first of all, if this a and this b are both positive, if we have x minus a times x minus b equals 0, we can set these factors equal to 0. X minus a equals 0, x minus b equals 0, which means my solutions are a and b. My x-intercepts are a and b. These are the places it's going to cross the x-axis. Now, if these are negative, it means that you're going to have x minus a minus a. That would give you x plus a. When you set that equal to 0, you'd have a negative x-intercept. So remember, just set the factor equal to 0. That's going to tell you where it crosses the x-axis. If these happen to be imaginary, no x-intercepts. Same factor occurs twice, it's a bounce. Imaginary factors, no x-intercepts. Now, the other thing that's kind of important about these quadratics that you use a lot of times in word problems is this vertex. Vertex is a minimum or a maximum value, and you can find that using your calculator if you graph it using second calc max or second calc min. This would be a minimum. It's a minimum possible value. It doesn't go down any further than that. Had it opened the other direction, had it been a frowny face, then you would have had a maximum. And you see that a lot of times in word problems. Occasionally we deal with inequalities. when we talk about quadratics. If it's greater than, that means you're going to shade the part above, and it means that you're going to graph the boundary line as a dotted line. So if I graph that as a dotted line and then shade the part above, then that would be what I would have if I had y was greater than some quadratic. If it includes the equal to sign, then you're talking about a boundary line that's going to be solid. And then again, we're going to shade the part above if it's greater than. If it is less than, then you're going to shade the part that comes below your quadratic. So this dotted line here, I would be shading, the solution would be the part underneath of this. And remember, this does not have to open up. It can open down. I could have a quadratic that has a boundary line that looks like this, and I have y is less than some quadratic opening down, and my solution is going to be this part here that's underneath of the quadratic. Less than with an equal sign included, it's going to be a solid line, and again, I'm going to shade the part that is underneath of the quadratic. That part that's shaded is your solution. When you talk about systems, if these are equations, you're talking about the points of intersection. So if I have two quadratics, or I have a quadratic and a line, and I'm looking for a solution to a system of equations, then the system of equations, the solution is going to be these 2 points of intersection, and I need to find both of those if it crosses twice. Inequalities, you're talking about the area of the shaded region that you shaded every time. So let's say that I have a system of quadratic inequalities where I have one quadratic that goes this way, and I shade the part underneath of it. So I shade this part underneath of that quadratic, and then I have a quadratic that opens the other direction and goes this way. Now the important question is, am I shading above it or am I shading below it? Well, if I'm shading below that particular one, again, then that means I'm going to shade all of this. Do not be deceived into thinking it's always the part underneath. Alright, so what part did I shade both times? Well, the part I shaded both times was this, that was underneath of both of those. So you need to pay attention. Am I shading above or am I shading below? The part that you shade both times is the solution to the system of inequalities.